Swayam Prabha. Digital India. Educated India.
Let us continue the problem related to probability. Already we discussed 3 problems of bivariate, that is joint probability distribution, and further some more problem we have to discuss. So, the problem is machine is used for a particular job in the forenoon and for a different job in the afternoon. The joint probability distribution of x comma y, where x and y represent the number of times the machine breaks down in the forenoon and the afternoon respectively, is given in the following table. Examine if x and y are independent random variable. So, the data is x and y, x0, y0 is 0, that is x0 and y0 is 0.1, x1 and y0 is 0.2, x2 and y is y0 corresponding 0.2, and similarly 0, 1, 2 corresponding to y1 is 0.04, 0.08, 0.08, and corresponding to is 0.06, 0.12, 0.12. Now, we have to check it out, x and y are independent. So, the rule is pi into pj equal to pij for all I comma j. So, let us find for pi into pj for all I in I and j. So, p0 is represent the addition of 0.1, 0.4, 0.6 and add them, you have what 0.2. Similarly, you calculate P1, P1 is nothing but 0.2, 0.8, 0.12 is 0.4, and then P2 is equal to 0.2 plus 0.08 plus 0.12 is 0.4, and we got the values of what P0, P1 and P2. Now, P0 into P0 star into P star 0 is equal to 0.2 into 0.5 equal to 0.1, which is equal to P of 0, 0. 0, 1 represent P0 into P star 1 is what 0.2 into 0.2 is 0.4 equal to P of 0, 1. P of 0, 2 represent 0.2 into 0.3 is equal to 0.06. So, similarly, we can verify that P1 star into P0 P star 0 is P1 0, and P1 1, P1 2, P1 P2 0, P2 1, P2 2, and we get that they are independent to one another. Next example, a joint probability distribution function of 2 random variable is given by f of x comma y equal to xy square plus x square by 8, where x lies between 0 to 2 and y lies between 0 to 1, and compute probability of x greater than 1 and probability of y less than of and probability of x greater than 1 by y less than 1 by 2. And the probability of y less than of such that x is greater than 1 and probability of x is less than y and probability of x plus y less than or equal to 1. Here the rectangle defined by 0 to 2. So, 0 to 2 here x axis and y axis 0 to 1, and we have the values start from y is less than or equal to 1, y is less than or equal to 1 is this is in the range, and 0 is less than x less than 2 is this. Therefore, we have to use the 2-dimensional random variable, that is double integral over r of f of x comma y dx dy. Here the function is given f of x y is equal to x y square plus x square 8 into dx dy, and now is integrate first innermost integral of 0 to 1 of x with respect to x is x square y square plus x cube by 8 over the limit. Say first you have to do with the help of y. Y you have to do that, that is integral this is x equal to 0 to 1, and here what y equal to 1 to 2 of x y square plus x square by 8 into dx. So, which is equal to innermost integral 0 to 1, and with respect to y and with respect to x is x into y cube by 3 plus x square by 8 into y, and over the limit 1 to 2 into dx, which is equal to integral 0 to 1 upper limit 2 cube, that is 8x by 3 plus here 2 x equal to the y equal to 2, therefore 2 by 8 x square, and the lower limit is y is 1, therefore x by 3 and x square by 8 over into dx. So, which is equal to 8 by 3 into x square by 2 plus here 1 by 4 into x cube by 3 minus x power 2 by 6 plus x power 3 by 24, and then we have the limit of 0 to 1. So, we have what it is 4 by 3 x square plus 1 by 4 into 1 by 3 minus 1 by 6 plus 1 by 24, which is equal to 19 by 24. So, this is the expansion of the double integral corresponding to the given function. This is a technique for finding the joint distribution function, probability distribution function. Now, we have to go to the next question is p of less than 1 by 2 in the subdivision. It means the integral y is less than half of the function. It means 0 to half and 0 to 2, and same idea you have to do, that is we have to go to the outer integral first with respect to y. Therefore, x into y cube by 3 plus x square into y by 8 over the limit 0 to 2 into dx, and then integral 0 to half with respect to x is x square by 2 into y cube, and then x square by 8 into 2 over the limit 0 to 2 applied dx. Here is 2 cube, 1 minute, the error occurred. Now, you have to innermost with respect to y. So, this is the integral 0 to half, and with respect to y. So, x into y cube by 3 plus x square by 8 into y over the limit 0 to 2 into dx, which is equal to integral 0 to half upper limit you have to do that, it become 2 cube is 8 by 3 into x plus here 2 into x square by 8 into dx, then integrate it 8 by 3 into x square by 2 plus what 1 by 4 into x cube by 3 over the limit 0 to half, and then here it becomes 4 by 3 into 1 by 4 plus 1 by 4 into 1 by 3 into 1 by 8. So, the resultant is 1 by 4. So, this is the way we can calculate P of y is less than half. Next one is P of x greater than 1 and y is less than half is integral r is x greater than 1, y less than half of the same. So, for the outer 0 to half, because here this is 0 to half, for x 1 to 2, maximum is 2, and then as usual the integral you have to do, and the limit we have 5 by 24. And probability of x is greater than 1 by y less than half is probability of x greater than 1 and y less than half divided by probability of y less than half, which is equal to, already we done that probability x greater than 1 less than half is 5 by 24 from here, and previous subdivision 2 we done it 1 by 4 and then we divide, so it becomes 6, therefore 5 by 6. So, this way we can do for joint distribution function of x greater than 1 such divide y less than half is a conditional probability, and the probability of x is less than y is the region x less than y of double integral region x less than y of the function xy square plus x square by 8 into dx dy, and we have a limit start from 0 to 1 and 0 to y. So, xy square plus x square by 8 dx dy, and innermost you have to integrate with respect to y, and then we have outermost with respect to x. So, we have 53 by 40, 480, because that is integral 0 to 1 x equal to this, with respect to y is x into y cube by 3 plus x square by y into y of dx, and then here the limit 0 to y, right. So, here this represent, so here this represent not with respect to y, with respect to x first you have to do, that is x square by 2 into y square plus x cube by 24 integral 0 to y, here integral 0 to y equal to 1 to 1, and then we have dy here. So, we have the limit integral 1 to 0 to 1 with respect to first 0 to y na. So, is here 0 to y. So, what happened? Y square is y power 4 by 2 plus here y power 3 by 24, lower limit is 0, therefore, with respect to dy. Now, we have to do the integration with respect to y, therefore, y power 5 by 10, here y power 4 by 24 into 4, and the limit is 0 to 1, therefore, 1 by 10 plus 1 by 4 into 24 equal to 53 by 480. Next one is the region is x plus y less than or equal to 1, and previously x is less than y, when y equal to x, then the region you have to take it. Here x plus y less than or equal to 1, then the double integral is x plus y less than or equal to 1 of xy square plus x square by 8 into dx dy, and we have to take the limit since x is independent, therefore 0 to 1, and y depends on x, therefore 0 to 1 minus y. And so this is varies from y, this is varies from x, this is x plus y, right. So this is x plus y is less than or equal to 1. If you take x equal to 0 and y equal to 0 to 1, and with respect to x, first you have to integrate it, and then put the limits 0 to 1 minus y, and then y equal to 0 to 1. We have 13 by 480. So this is the way we can do the problem. Next example, if the joint probability density function is given by f of x y equal to 1 by 2 pi sigma square into exponential of minus of x square plus y square by 2 sigma square, and x comma y lies between minus 1 infinity to plus infinity, find p of x square plus y square less than or equal to a square. So the entire xy plane in the range of R, space R, the even space D is interior of the circle x square plus y square equal to a square. Therefore, probability of x square plus y square less than or equal to a square equal to double integral x square plus y square less than or equal to a square of f of x comma y into dx dy. So the transform from Cartesian system to polar system, put x equal to r cos theta and y equal to r sin theta. Therefore, we have to calculate dx dy, which is equal to dou x by dou r, dou y by dou r, dou x by dou theta, dou y by dou theta into dr d theta. So x equal to r cos theta. So differentiate x r cos theta with respect to r is cos theta, and differentiate y with respect to r is r sin theta is sin theta, and x with respect to theta, therefore minus r sin theta, y with respect to theta is r cos theta into dr d theta. So which is equal to determinant expanded is r into cos square theta plus sin square theta into dr d theta, which is equal to 1 into dr d theta. So this is the answer for what r dr d theta if you use in the Cartesian to the polar. Since it is a circle, therefore 0 to 2 pi, therefore 0 to 2 pi, and with respect to r is 0 to a radius, and then we have a function 1 by 2 pi sigma square into e power x square plus y square, x square plus y square equal to, here is r square, therefore here it becomes r square by 2 sigma square into r into dr d theta. So 1 by 2 pi is take it outside, and then integral 0 to 2 pi keep as it is, e power r square by 2 sigma square integrate it. So e power minus r square by 2 sigma square by sigma square get cancelled, we have e power minus r square 2 sigma square only will come 0 to a, put r equal to a, therefore 1 minus e power minus a square by 2 sigma square, and then lower limit is 0, minus or minus plus 1, therefore 1 will come. Now integrate with respect to theta. So 1 d theta is theta, so this is the value of this here theta, minus with respect to theta we have what totally it is associated with the constant, therefore d theta only will come. So what happened, everything in terms of this is equal to 2 pi, and 2 pi get cancelled, therefore 1 minus e power minus a square by 2 sigma square is a net answer. And next we have example. A gun is aimed at a certain point origin of the coordinate system. Because of the random factors, the actual hit point can be any point of x comma y in a circle of radius r about the origin. Assume that the joint density of x and y is constant and this circle is given by f of xy of x comma y is c for x square plus y square less than or equal to r square, 0 otherwise, and calculate compute c and show that fx of x equal to 2 by pi r into root of 1 minus x by r the whole square for minus r less than or equal to x less than or equal to r, 0 otherwise. So, the solution is here, the range space is the interior circle. So, by the joint probability density function, the integral x square plus y square less than or equal to r square of f of xy into dx dy and double integral x square plus y square less than or equal to r square is c into dx dy of 1 and double integral x square plus y square less than or equal to r square is f of xy is c, therefore c into dx dy. So, the is equal to 1. Now, changing the polar form to coordinate, therefore, for outer circle 0 to 2 pi where inner circle 0 to r and dx dy is what r into dr d theta already derived. So, the net value is what c equal to 1 by pi r square after integrating, because so the integral is here I explained. So, when innermost circle c take it outside, so r square by 2 over the limit 0 to r. So, integral over 0 to 2 pi of d theta. Now, c by 2, right, c by 2 into r square by 2 and then into d theta. So, c by 4 here, c by 2 already we taken a 2, therefore, this is what r square, right, this 2 do not take this, these 2 is exist and d theta. Now, integral over theta, therefore, c into r square of t theta hold the limits 0 to 2 pi, therefore, c into r square into 2 pi which is equal to 1, right, c equal to 1 by r square pi. So, this is the way we can calculate the value of c from this step. Next, we have defined earlier that fx of x equal to minus infinity to plus infinity of f of x comma y, right. So, the definition holds good if the range space is the entire xy plane. If the range space is different from the entire xy plane of fx of x is given by integral f of x comma y dy, for which the limits are fixed as follows. Draw an arbitrary line parallel to y axis. So, the y coordinate of the ends of the segment of such a line that lies within the range space or the required limits. So, these limits will be either constant or function of x. Therefore, we have a circle, this is the corresponding demonstration of the circle, where a equal to x comma minus root of r square minus x square and b equal to x comma root of r square minus x square. Therefore, fx of x is integral minus root of r square minus x square to r square minus x square of 1 by pi r square of dy, and integrate it, you have 2 by pi r into root of 1 minus x by r the whole square, where x varies from minus r to r. Next example, the joint probability distribution function is given by f of x equal to kxy into e power minus of x square plus y square, where x and y are positive. Find the value of k and prove also that x and y are independent. Here the range space of the entire first quadrant of the xy plane. Therefore, x is positive and y is positive. So, this is the first quadrant. Here x and y are positive. Now, k into xy into e power minus x square plus y square into dx dy is a given function. Substitute it. Now, separate y and separate x, so that the problem reduces to with respect to y with respect to x. After integration by parts, we have the value of this is equal to 1 by 4 into k, which is equal to 1, and cross multiply k equal to 4. Now, we have f of x over x is integral 0 to infinity of 4x into e power minus x square into e power minus y square dy, which is equal to 2x into e power minus x square, which is equal to x is positive, and fy of y equal to 2y e power minus y square, where y is positive. Therefore, fx of x and fy of y is nothing but 2x e power minus x square into 2y e power minus y square equal to 4xy into e power minus of x square plus y square. This is a function. Therefore, the random variable x and y are independent. So, note that fxy can be factorized into product of two functions, then x and y will be independent. Next example, given fxy of x comma y is cx of x minus y, where 0 less than x less than 2 and minus x is less than y less than x. Otherwise, evaluate the value of c and find f of x over x and f of y divided by x over y by x and d of f of y over y. Now, the picture is, if y equal to x, it start from origin, go like that. If y equal to minus x, it goes like that. And then joining together of these a and b, so that the structure will come. And here x stands for what, 2. So, this is the straight line x equal to 2. This is a picture where the transformation is given. Now, the bivariate variable is given. Now, start to evaluate the function. Here the range space is the area within the triangle OAB. So, as per the figure, when x varies from 0 to 2 and y varies from minus x to x, so the integral is double integral cx into x minus y into dx dy equal to 1. So, what we have to do is the range of the triangle OAB is, so first x is independent, therefore 0 to 2, and y is varies from minus x to x, therefore minus x to x is given. So, now you have to do the integration first with respect to y. Now, what I have to do? Cx into x minus y, right. So, we have what? Integrate with respect to y, therefore, it becomes xy minus y square by 2 and then over the limit minus x to x into dx. Now, we have integral 0 to 1, upper limit is what? X, therefore, x square, here x square by 2 minus of lower limit is cx into minus x square minus x square by 2 and everything with respect to dx. So, integral 0 to 1, now we have x square minus x square by 2, 1 minus 1 by 2 is off, therefore, cx into x square by 2, that is x cube by 2, here minus x square by 2 is what? Minus 3 by 2, minus to minus plus 3 by 2 into x square, it becomes x cube into dx, which is equal to 1. Now, we have to integrate. So, c into x power 4 by 4 into 2 plus 3 by 2 into x power 4 by 4 over the limit what? Over the limit, here also c is associated, over the limit 0 to 1, which is equal to 1. Now, we have what? C, 8c is equal to 1 will come, therefore, c equal to 1 by 8. Next subdivision, fx of x is integral minus x to x 1 by 8 into x minus y into dy. So, here integrate it 1 by 8 into x square y minus x into y square by 2 over the limit minus x to x, which is equal to 1 by 8 into upper limit is x cube minus x cube by 2 minus of lower limit is minus x cube and then minus x cube by 2. So, 1 by 8 is common to all. Here 1 minus 1 by 2 is 1 by 2. So, x cube by 2. Here what? Plus x cube plus 1 by 3 is 3 by 2 x cube, and then the value becomes what? X cube by 4. So, that is the net value. Similarly, we have f of y over f x is f of x comma y by f of x equal to 1 by 2 x square into x minus y, where y lies between minus x to x, and fi of y equal to integral minus y to 1 by 8 into x into x minus y dx in the interval minus 2 to 0. Therefore, integral y to 2 1 by 8 into x of x minus y dx in the interval 0 to 2. Therefore, we have the function fi of y is 1 by 3 minus 1 by 4 plus 5 by 48 into y cube when the interval minus 2 to 0, and 0 to 2 we have 1 by 3 minus y by 4 plus 1 by 48 y cube. Now, we have another problem. Train X arrives at a station at random in the time of interval 0 comma t and stop for a minute. Train Y arrives independently in the same interval and stops for b minute. Find the probability of P1 that X will arrive before Y. Find the probability of P2 that two trains meet. Assuming that they meet, find the probability of P3 that X arrived before Y. Let the trains X and Y arrive at the station at the time of instances X and Y respectively, X and Y instances respectively. Then the lengths of the intervals 0 comma x and 0 comma y, namely x and y, are continuous random variable. Each of x and y is uniformly distributed in 0 comma t. Since the time of arrival are equally likely with probability density function is 1 by t. Since the two trains arrive independently x and y are independent of random variables. So, the joint probability distribution function x comma y is given by f of x comma y equal to f of x over x into f of y over y equal to 1 by t square, where 0 less than or equal to x into comma y less than or equal to t, because both the PDF is 1 by 2, 1 by t is given, therefore 1 by t into 1 by t is 1 by t square. Therefore, the range space is the square defined by 0 less than or equal to x less than or equal to t and 0 less than or equal to y less than or equal to t. Therefore, P1 equal to probability of x less than y is double integral over x less than y of f of x comma y into dx dy in the triangle OBC. So, this is the picture where x equal to y and x minus y equal to minus a and x minus y equal to b is a picture corresponding to the given statement. According to the previous step, then 1 by t square is double integral over dx dy in the area of OBC. OBC. You take it, so this triangle and then this triangle and then OBC you have to take it. Therefore, the area of the triangle OBC is equal to twice of the t square, therefore t square get cancelled, therefore half will come. So, 1 by 2 into this will come and then that value is 1 by 2. So, the train x arrives first. So, two trains will meet if y is less than or equal to x plus a. If train y arrives first, then two trains will meet if x is less than or equal to y plus b. For the two trains to meet, we have what? Minus a less than or equal to x minus y less than or equal to b. Therefore, P2 is such that P of minus a less than or equal to x minus y less than or equal to b, which is equal to double integral over OBD ODEBGFO of f of x comma y into dx dy, which is equal to 1 by t square into a area of the figure ODEBGFO. So, it seems to be the trapezium of ODEB and that of the OBGF into 1 by t square. Therefore, 1 by t square into area of trapezium of ODEB and that of OBGF. So, you know the area of the trapezium, half into length into breadth of this trapezium, or you take it, or b by root 2 into t minus b into root 2 plus t into root 2 and then half into a by root 2 into t minus a root 2 plus t into root 2. So, simplify, 1 by t square is common to all and 1 by 2 is also common, therefore 1 by 2 t square. So, which is equal to a into 2t minus a plus b into 2t minus b, which is equal to 1 by 2t square into twice of a plus b into t minus of a square plus b square. So, this is the answer to the second one. Next, P3 is p is less than y such that minus a less than or equal to x minus y less than or equal to b. Therefore, probability of x less than y and minus a less than or equal to x minus y less than or equal to b divided by p of minus a less than or equal to x minus y less than or equal to b is area of the trapezium of OBGF into 1 by t square by P2. So, which is equal to a into 2t minus a by twice of a plus b into t minus of a square plus b square. Already we done it, that you have to substitute here and then the denominator P2 will be derived already, that check it out and substitute it, and the area of the trapezium of OBGF is already done it, then simplify, you have 2t minus a. So, the net value of P3 is equal to a of 2t minus a by 2 into a plus b into t minus of a square plus b square. Next problem. Two trains arrive at a station at random between 7 am and 7:30 am. One train stops for 5 minutes and another for x minutes. For what value of x will the probability that the two trains meet be equal to 1 by 3? According to previous problem, here t equal to 30 and then a equal to 5, b equal to x and P2 equal to 1 by 3. Now substitute directly the formula. So 1 by 2t square into 2 of a plus b into t minus of a square plus b square equal to 1 by 3. This is a P2. Now a is 5, b is x and t is 30. 30 the whole square is 900 into 2 is equal to 1800 and 60 into x plus 5 minus of x square plus 25 equal to 1 by 3 and cross multiply, simplify, we have x square minus 60 plus 325 equal to 0. Therefore, factorize x equal to 53.98 or 6.02, whereas if you take x equal to 53.98 then it is a meaningless. Therefore, x equal to 6 is a minimum nearly will come. So, that is the answer to the question. Next example, the two-dimensional random variable x comma y follows a bivariate normal distribution n of 0, 0, sigma x, sigma y, or find the marginal density function of x and the conditional density function of y given x. So, the solution is the notation n 0, 0, sigma x, sigma y r refers the bivariate normal distribution with the mean of x equal to mean of y equal to 0. The variance of x is sigma square x with respect to x, y equal to sigma y square and the coefficient of correlation between x and y equal to r. Now, the joint PDF of bivariate normal distribution is f of x comma y equal to 1 by 2 pi into sigma x sigma y into root of 1 minus r square of exponentially minus 1 by 2 into 1 minus r square into x square by sigma x square minus 2 r x y by sigma x sigma y plus y square by sigma y square, where x comma y lies between minus infinity plus infinity. Now, we have the marginal density function fx of x equal to integral minus infinity to plus infinity f of x comma y dy. So, given f of x comma y, substitute here. Therefore, a into integral minus infinity plus infinity exponential of minus of 1 by 2 into 1 minus r square into y by sigma y minus rx by sigma x whole square into exponential of minus x square by 2 sigma x square dy, where a equal to 1 by 2 pi sigma x sigma y into root of 1 minus r square. Now, after simplification, this becomes a into sigma exponential of minus x square by 2 sigma x square into 2 into root 2 sigma y into root of 1 minus r square over the limit minus infinity to plus e power minus t square dt is a error function, and we can correlate into beta gamma function, so that this becomes the value is t. Now, we have 1 by root 2 into 1 minus r square into y by sigma y minus r into sigma x equal to t. Therefore, a into exponential of minus x square by 2 sigma x square into root 2 into sigma y into root of 1 minus y square into gamma of. So, root of integral minus infinity plus infinity is e power minus t square dt is corresponding gamma of, and then the resultant will be reduces to 1 by 2 pi into sigma x sigma y into root of 1 minus r square of exponential of minus x square by 2 sigma x square into root 2 into sigma y into root of 1 minus r square into root pi, and further simplify we have 1 by sigma x into root pi of exponential of this. So, which is the density function of normal distribution n of 0 comma sigma x. Therefore, the conditional density function y of x is given by f of y by x equal to f of x comma y by f x of x. Therefore, f of y by x equal to 1 by 2 pi into sigma x sigma y into root of 1 minus r square equal to exponential of minus 1 by 2 into 1 minus r square of x square by sigma x square minus 2r xy by sigma x sigma y plus y square by sigma y square r by denominator is sigma x into root pi into exponential this. Here we have to take exponential of minus 1 by 2 into sigma y into 1 minus r square common, and simplify you have this formula, and then 1 by root pi into 1 by sigma y into root of 1 minus r square is equal to exponential of minus 1 by 2 into sigma y into root of 1 minus r square into y minus r into sigma y x by sigma x the whole square. So, this is called it as density function of normal distribution.